Hey everyone, welcome back to the channel. It is great to have you here. I know, it's been a while. It's been over 5 months since I last posted a video. I've been quite busy with a lot of things, but now I'm back and I have a ton of content coming your way in the next few days or so. If you're into financial modeling, energy markets, and now even into Bitcoin mining, make sure to stay tuned. To kick things off, today's video is all about the levelized cost of storage. The reason why I'm starting with this video is that I've recently updated all the levelized cost of energy models available on my website. Now, you can choose between multiple models, from standalone solar, wind, and battery systems, all the way to hybrid solar wind, battery, and much more. Check out the updated LCOE models by clicking the link in the description below. Next up, I will be covering something completely different, but just as exciting: how to build a financial analysis for Bitcoin mining from scratch. I will go through and analyze a single mining unit all the way to modeling a full-scale, utility-level Bitcoin farm. I'll break down the key financial considerations, risks, and most importantly, whether it is even worth running a Bitcoin mining operation in the first place. And that's not all. I'm also preparing a project finance financial modeling course, which will be available here on YouTube and other platforms. So, if this sounds interesting to you, make sure to hit the subscribe button and turn on the notifications so you don't miss anything. Now, let's dive right into today's topic: the levelized cost of storage. All right, so this is the LCOE battery model that we're gonna work with today. This is the updated version that you can click on the link below and get your version. We have a couple of sheets in here. We have the cover, the results sheet with two graphs. We have also the input sheet, the calculations sheet, and the setup, where we have the constants and the check. So what I'm going to do here for us to build this model from scratch, I'm going to basically delete the calculations. So I'm going to select all these sheets. I'm going to delete. I'm going to go back. Then I'm going to go to this one here. I'm going to also delete here and over here. And of course, the graphs are no longer working. So let's going to see how to start the model, right? So we have to first put a start date. I'm going to put in like 31st of December 2025. Well, let's put 2024. So that's basically what we had before. I think before we had 2022. Then we're going to have the construction period. So how long it's going to take for us to build up the project. So we're going to say 4 quarters. Then for the operation period, we're going to say this power plant or this battery is going to work for 10 years. And the interval between periods is our timeline, how long is going to be each period in our timeline. So here you can see I'm set up these as quarters. Okay, we're going to say it's going to have 2 quarters. So basically our timeline is going to have in each period 2 quarters or 6 months. All right, so what is the assumption here? So the assumption for this model is that the battery system is going to receive or charge itself from an external source. Okay, it doesn't really matter where the source comes from. What matters here is the cost of this electricity that we are receiving. Okay, so what we're going to do first, we're going to come up with how much generation goes every single year from the battery to the load. Okay, I'm going to just have here a number. It doesn't really matter what the number is. Okay, but I'm going to just leave this 3,250 megawatt hours per year. And again, we're not checking or not considering anything other than discharging the battery. Okay, so we're not providing, I'm not stating here whether we're going to do ancillary services or whether we're going to do some sort of peak shaving or just being able to provide extra electricity for some load. I'm just saying here that this battery is going to provide 3,250 megawatt hours per year. Okay, so that's the assumption of the model. Then here we're going to say how much you're going to pay for each megawatt hour to charge the battery. So we're going to say we're going to pay $35 per megawatt hour. So that's our cost. Then we're going to have here the efficiency. So this is a very important parameter in the model because that's going to tell you how much energy we're going to need in order to charge the battery, okay, or to produce this amount of electricity per year. So let's say here our battery system has an 80% efficiency. So we can pretty quickly calculate here how much electricity we're going to have to purchase every single year, which is going to be the total generation to load divided by the efficiency. Okay, so this is how much energy we're going to have to purchase every single year. Then because we only have an efficiency of 80%, then this is how much we're going to be able to send to the load. Okay, so that's basically how it works, and that's why that's a very important parameter in the model. Now we have the capex and the opex. What we're going to say here is that our system has a 15 megawatt and a 15 megawatt hour per cycle. So it's a 1 hour battery system. We're going to leave the cost of the capex on a per kilowatt base as 0. And I'm going to say that the cost of the battery per kilowatt hour is going to be $110 per kilowatt hour. All right. So now we have to calculate what is the total cost of this battery system. So we have two components. We have a capacity component and we have a energy component. So we're going to say that this cost is going to be equal to the total capacity times the cost per capacity. But just pay attention here. We have a megawatt system and are charging per kilowatt. So we're going to multiply by 1,000 and already set up a named cell for 1,000. Okay, so I'm going to show you where that is. Let me just finish the formula here. And then I'm going to say plus, we have to add now the energy component, which is going to be the total capacity per cycle times the price per cycle, or the price per cycle. And of course, there's a different unit. So we have megawatt hour and kilowatt hour. So we also have to multiply by 1,000. Sorry, 1,000. There we go. I'm going to press enter. And this is the total price for the battery system we have over here. So if you're wondering where the 1,000 is coming from, so if we'll go to setup, and if you click on cell E4, you're going to see that I named this as 1,000. So whenever I use the word 1,000 now in a formula, I'm going to press F9 here. It's going to mean 1,000 number. Okay, so this is what we have over here. And as opex now to finalize, we're going to say that the total cost per kilowatt hour per kilowatt per year is going to be 15. All right, so this is also in kilowatts, so we have to pay attention once we go to the calculation sheet to make sure that this number is correctly translated into megawatt. All right, so we have some other inputs in here. Okay, I'm going to say that we're going to have some other capex. It's going to cost us, let's say, $500,000. Let's say for connection to the grid or whatever, doesn't really matter, just for the sake of the exercise. And also that we're going to have a $25,000 per year as an opex for this other capex, which I'm assuming is a grid connection. If that is the case, you can either change the name here for grid connection. It doesn't really matter. And of course, if you have been following the channel, we know whenever we do LCOE calculations, we have to use NPV the cost and the generation. And whenever we use NPV, we have also to use a discount rate, which we're going to say it's 4.5% per year. All right. So that's basically what we have here. Now we have to calculate the dates over here. So I'm going to say start and end. I'm going to select them. I'm going to go to home and I'm going to click on the styles and I'm going to say table. So the start date for the construction period is going to be equals to the model start date, which is the last day of the year, plus 1. So that's going to be 1st of January. And the end of the period of the construction period is going to be 4 quarters later. So it's going to be end of month. I'm going to press tab. Start date is the start date of the construction period, comma. Then we have 4 quarters. How many months in a quarter we have? Months in quarter. Minus 1 and close it. 31st of December 2025. That's correct because that's 1 year. Then we're going to have that the first date of operation period is the end of the construction period plus 1. So 1st of January, and then we're going to have 10 years. It's going to be equal to the end of the month. Start date is the start date of the operations period, comma. We have 10 years time times months and year minus 1, close parentheses, and enter, and that's where I'm going to finish. Okay, so we have the input sheet pretty much done. This one here was before where I was having the flag to check if the model is correct, or I'm going to delete it for now. We can do it later. And we're ready to go now basically to the calculations sheet. So let's do it. All right, so let's gonna click on calculation. We have our calculation over here. This is also where let me just go back here. This is just a bug. So this is where we were having the flag before. Let me delete it for now. It doesn't really matter. So the start date, that's the first thing I'm gonna do. So we're gonna say, actually here we have the start and end. Here we have the periods per quarter, so you just have to change here, so it should be periods per I'm gonna just say periods here. That's the interval that we're gonna have here, so the interval between periods, 2 quarters, right? So then we have the start date, so I'm gonna go over here, grab the start date. I already named it, you can see it. It's const start date. I'm gonna copy and paste. Actually, I can't. I have to say equals to the should be ends, and operations ends over here. Then it's gonna be equals to the construction start, and here's gonna be equals to const end. Okay, and again, because I just got this from the model that I'm gonna make available for you guys, I named all these cells over here. You can see construction start date, construction end, operations start, and operations end. So that's something that you always should do on your end. Name cells and range just to make your model more robust. All right. So let's gonna see what we're gonna have over here. So basically, now I understand it should be start here, because here we're gonna have the start date and here we're gonna have the end date. So here we're gonna have the model start date, which is this one over here, and I also named it before. So there we go. So here's gonna be equals this date plus 1, and now we have to calculate the end date, right, for the first period. So that's gonna be equals to end of the month. All right, so the start date's the one above. How many months we have? We have quarters times months and quarter minus 1. We're gonna close parentheses, and here we go. So that's going to be 3rd of June 2025. So now I can select and copy everything across. And what is okay? I have to properly anchor this value over here. So I'm gonna press F4 once. So I'm gonna anchor it. If I copy and paste everything across, everything should be corrected right now. Very cool. So here we're gonna have our flags, right? So how do we do our flags over here? So let's see how to do it. We're gonna say basically what we have to say, if these dates here, if in the periods here falls in between these two dates, sorry, the period here falls in between these two dates, we should have 1 or true. Otherwise, we should have 0, right? So let's see how to do it. So it's gonna be equals to if what? If this date, I'm gonna press F4 twice, should be what? This date here should be greater or equals to this date. I'm gonna press F4 3 times. Or, right, so I have to have an or condition here. So let me say, or and should be both, right? So this and what? And these dates here, I'm gonna press it for 2 times, should be less or equals to this date over here. I'm gonna press it for 3 times, and I'm gonna close it. Let's see what's wrong here. Yes, because I have to press this one here. Okay, let's see what's missing. Oh, I don't need the if. Sorry, I can get rid of the if, and I can basically get rid of this. There we go. So that's true. I'm gonna use 1 because that's, let's see, if. So if this is true, then we're gonna have 1. Otherwise, we're gonna have 0. Let me select this. That's correct. Let me copy and paste across. Let's see if that's correct. It seems to be correct, or it's not correct. There's something wrong with the dates here. It's 35. Why is this 35? So strange. Oh, this is not ops. Oh, should be here, should be construction end. Okay, should be construction end here. Oh gosh, construction and here should be equals to ops, and now it's correct. All right, so now we have the correct date over here. We have 1 and 1, and if I did everything correct, and if I copy and paste everything across here, it should... What is wrong here? Let's see what is wrong here. Copy and paste across. It's just the logic of the formula. Okay, let me copy and paste this. This is correct. Okay, I have to change the... Let me fix this. So let's see. K2, it should be greater than... this is wrong also, right? Should be ops equals ops started. Yeah, now it's correct, right? So this is 0, this is 0, everything else is 1, and then in 35 we finished. Okay, so I just made a inverted everything here, but everything is correct now. So this is construction, this is operation. That was a mistake I did. All right, so I'm just gonna set this to be a int sheet calculation, so just to label it as it, so it's easy to understand what's being done. And we have fixed our timeline calculations. Right, let's gonna move on now and do the calculations for our counter. So first we need to count the number of periods, the number of days per period. So that's quite straightforward. It's going to be equals to the end of the date minus this date here, and of course we have to add 1. Okay, so let me see if that's correct. Copy and paste across. I always get confused whether... Yeah, that seems to be correct, right? So we have 3. Yeah, that seems to be correct. And here we're going to have a leap year. So that's correct, right? So next we have to know which construction quarter this is. So basically the way to do it's quite simple. So we're going to say equals sum. I'm going to say, and then I'm going to say like this. We're going to fix this one here, and I'm going to close it. There we go, copy and paste. And what we need to do now, we also have to multiply by the flag. So we're going to multiply by this. I'm going to press F4 twice, copy and paste, and there we go. So this is correct. And I think if I copy and paste this one below here, let me see, I just have to move this one over. Let me see the copy, and this one goes over here and should be operations quarter. Let's see if that's correct. Yeah, this is correct also, right? So that's basically what I did. So I'm summing, and then I multiply by the flag, and everything is working properly. All right, so we have everything here, and these counters here are important because, and the days, because we need to accommodate for the units, right? So basically everything that we had as an input is based on years, right? So this is based on year, on year, on year, and here eventually you're gonna have quarters or months or whatever you wanna have over here. Cool. So our discount rate was given at the end over here, and there we go, it's 4.5%, and this is percentage per year, so that needs also to be fixed eventually. So let's see how that goes. Okay, so what we're gonna have here, I'm gonna use all the columns in here to calculate or to bring the numbers from the other sheet, and here I'm gonna calculate the NPV. Okay, so this here will be all the NPVs. I'm gonna calculate them. So NPV, NPV, and NPV. And here I'm going to bring the generation, right? So we have the generation, then we're going to have the capex, the opex, and here I'm going to calculate the LCOS basically. Okay, so what we're going to have here, I'm going to have a megawatt hour per year. Generation from battery to load, we have that number, and this number is up over here. There we go. Then we have our efficiency. The efficiency is over here. So basically I want to calculate what is our total energy needs. All right, so how that's going to go, I'm going to say that this number here is going to be equals to this. Remember, we have megawatt per year, so I'm going to press F4 3 times here just to fix it correctly. And I'm going to multiply by what? By the number of days. I'm going to press F4 twice to properly anchor it. And I'm going to divide by days in a given year, which is 365 because I set it to... So second, what's going on here? why it's not. Let me just go over here. Yeah, it should be equals here. Okay, there. I don't know what happened, but here we go. So I set the number of days in a year over here, as you can see here. All right. So cool, but this is not correct because this is the generation only during the operation. So we also have to multiply by the flag over here. Cool. I'm gonna copy and paste across. There we go, and I'm gonna say equals to the sum and copying everything over here. Okay, so if I'm going too fast for you and really not able to follow along with me, I would recommend you just to watch some of the other videos that I did on how to build LCOE. I have a whole series on how to do it, and we are going to be able to find a link for this playlist in the description below. All right, so let's going to calculate the NPV now. And I'm calculating the NPV here just because it gets easier later on for me to come up with all the numbers for the LCOS, because we need to have the LCOE or the NPV of every single generation stream and then the cost, right? So I'm going to say the NPV is going to be equals to the X NPV. And again, if you're not sure why I'm using the X NPV instead of the NPV, I would recommend you to watch the video that I did on NPV against X NPV. You want to use either one of them. So we have the X NPV here, we have a rate. So this is our rate. I'm going to fix it. I'm pressing F4. Actually, I don't need it because I already named these as the discount rate. The values are going to be these ones over here. And then I am going to get the dates. I'm going to bring the dates over here. Okay, so that's what we have. And just for the sake of the exercise, what's happening here, okay, I'm calculating the NPV to the 30th of June 2025. Okay, so that's when I'm evaluating all the streams for this model. Okay, good. So that's when you're evaluating your cash flows. I can also copy and paste this cell over here. It's 0 because there's nothing here. So what we have to do, we have to say this total energy needs going to be equals to the generation from BS to the load times the, divided by the efficiency. I'm going to press F4 to properly anchor, and I can copy and paste across. And here we go. What's wrong here? I am not really sure what's wrong, so let me copy and paste this across. Okay, what is wrong here? Okay, I didn't properly anchor this thing over here. This should be right over here, and there we go. So this is correct. So what I'm gonna do, I'm gonna fix this. I am going to fix this number over here. So this, I'm gonna press F4 and F4. So now if I copy and paste things across, they will always match and fix the calculations on the correct dates. All right, so that's why it's always important to make sure you anchor your formulas correctly. Next, we're going to calculate the capex now. So the capex, we have the cost, so the BS system and other costs, right? So for the battery, we have a total cost of 1.6 million. And then for the other costs, we have equals to, what is it? This is going to be equals to 500,000. Cool. So now we can basically copy and paste the NPVs. I also want to copy and paste all the sums, so we don't need to redo it. There we go. So what's going to be the cost, right? Let's see how to do it. So basically we're going to assume we're going to split the value here in two, right? So our capex is going to be disbursed half on the first period, half on the second one. So how can we properly do it in the most concise way? So let's see how to do it. All right, so what we're going to do here, we're going to say the following. It's going to be equals to what? It's going to equals to be this number here. I'm going to press F4 3 times, multiplied, or actually divide by what? I need to know how many periods we have during construction, right? So we have 2, so we're going to say equals to the sum. I'm going to sum everything, and I'm going to press F4 here. I'm going to close brackets, times, and then I need also to multiply by the flag, right? So what's going to happen? Let me show you guys. So basically what this is doing, it is getting the number as the total capex and dividing it by the total number of periods we have during the construction phase, right? And then just checking whether we are under the construction or not by multiplying by the flag over here. I'm going to press it for 2 more times, and I'm going to copy and paste everything across. Okay, so this is working correct. Let's say now we were to have a construction of not only 4 periods, but let's say 8 periods, right? So let's gonna go back here. So the good thing is we still have everything correctly here. So we have 2 years of construction, which is equals to the 8 quarters, and the sum here is equals to the total capex. Okay, and let's see now if we're gonna have 4 quarters per period. Okay, everything is still matched quite nicely over here. So I'm just gonna go back here. I'm gonna say we're gonna have a construction period of 4 quarters, and we're gonna have interval between periods of 2 quarters. There we go. Okay, so that's correct. I think I can just copy and paste across if I did everything correctly, and apparently I did. So I can copy and paste across, and we will have here the correct numbers for the capex. What we have to do now, I'm going to press Alt equals to sum everything, and I'm going to copy and paste across. And there we go. So let me just read Alt ES formulas. And there we go. So everything seems to be calculated correct over here. Okay, let's going to move on now to the opex. So let's going to grab the opex. I think we have always cost per year. So what is the opex for the battery? It's going to be equals to, let me see over here, it's going to be equals to what? Where's the opex? We have the opex over here, right? So it's going to be this number multiplied by how many kilowatts we have. We have 50 megawatts times 1000, right? So that's the number or the total cost per year. And the other costs, I think that's the plan number. There we go, $25,000. And for this one here, we can get rid of. We don't need this one here, so let me just delete it. Okay, cool. I'm gonna grab and copy the NPV. Sorry, should be Control C. So here's Control V, and I'm gonna press Enter. So how to calculate the cost per year? So it's gonna be equals to this number. I'm gonna press F4 3 times, multiplied by the days per period, divide by the days in a period, divide by the days in a year over here, and I'm gonna press Enter. I also have to multiply by the operations flag over now, and I'm gonna press F4 twice now to properly anchor the number. Okay, I'm gonna Control D to copy it from above, and that's wrong because I also need to properly anchor this one. I'm gonna press for twice, Control D, and I think now everything is correct, so I can copy and paste everything across. And here we go, right? So we have basically, if I add these 2 numbers here, which represents the full year, I'm gonna have a total of 225, which is exactly what we have in here, and the same here. So we have $25,000, which is exactly like this number over here. So everything seems to be correct here. And let me just go to the end of the model. Yes, everything is matching properly the model over here. Okay, so what is going to be our total energy cost? So that's the important factor, right? So how to calculate our energy cost, because that's an opex, right? And if you remember correctly, we have a cost for the energy here. So what I'm going to do here, I'm going to say energy costs. That's going to be USD per kilowatt hour. I just want to copy and paste the style, and that's going to be equals to the $35 per megawatt hour. So that's correct. Let me just set it as an off and as a comma like this. All right, so what's going to be our energy cost? It's going to be equals to the cost. I'm going to press F4 3 times, and I'm going to multiply by how much energy we are purchasing or using to charge the battery, right? So pay attention. It should be your total energy needs, not the generation from BESS to the load, because that's how much energy you're purchasing. Okay, so let me just delete it, and I'm gonna also multiply this by the flag over here. I'm gonna press F4 twice, and I'm gonna do the same over here. I'm gonna copy and paste across, and that's the number we have. Okay, and now the total cost is going to be equals to the sum of this number, comma, this number over here, close parentheses, enter. I'm going to copy and paste everything across, and here we go. So this is how much energy we are consuming for the whole year. Okay, so basically now we have the most of the calculations, everything is in place. The only thing we have to do now is to calculate the LCOS, which is going to be pretty straightforward now. All right, how we're going to calculate the levelized cost of the battery or the storage is going to be equals to the sum of our opex and capex is going to be equals to this, comma, this, right? And we will now divide it by what? By the total generation. Which generation we're going to use? We're going to use the generation to load or generation or total energy needs. We're going to use the total generation from BESS to the load. Okay, and the reason being is because that's the generation that's going to produce revenue for the company. Okay, that's the useful energy, right? So we're going to press enter, and this is the price of our battery system. Now we can also get here the efficiency. I'm gonna go over here and press okay. I don't think we're gonna need this information, to be honest, but that's in here anyway. Right, so now let's gonna calculate the breakdown. Right, so we can do a breakdown of the energy costs here, and can be very nice to do it. You're gonna see why. So what is the LCOS only for the capex? So it's gonna be equals to what? The capex, or let's see, let's put here a bit different. So it's gonna be the BES capex, the BESS opex, other capex, other opex, right? And I also want to have here the let's say charging, electricity charging costs, right? So I'm gonna copy and paste everything across, and I'm gonna see if everything matches now. So what is the BES of the capex? The LCOE of the capex is going to be equals the capex divided by the generation. Okay, for the opex it's going to be the same thing. So the BES opex, this number here, divide by this number. Then we're going to have the electricity charging cost, which is going to be this number divided by this number. The other capex is going to be equals to this number divided by this number. And now we're going to have the other capex, which is going to be this one divided by this one. And if we add all these things together, we should achieve the same result, which we do. So basically what I can say here, I'm going to say this number equals to this one here. And if this is true, which it is, then our model should be correct, right? So let me say LCOS, and there we go. Okay, so that's basically it. We have our LCOE here. What we can do now, we can say Ctrl+C, and I'm gonna paste over here, Alt+ES, let's say link. There we go. So we know that this is true. I can now copy this, and I can paste it over here, just to give to you an indication that, or let me just go back here and copy. And I'm gonna Alt+ES formula. So I'm pasting here, and I can also paste over here, which is already over here. Enter. I can copy. I'm gonna paste the style, Alt+ES formats, and Alt+ES formats. Alt, enter. So you can see now the visual sign that your calculations are correct. And if you go to the results page here, I already linked all the cells. We can see the breakdown of the capex, right? And now quite easily you can build a graph, right? I'm not gonna do this because that's not the purpose of the video today, but you can quite easily build up your capex codes or graphs, and you can see the breakdown for each one of the costs. What I can do now, I can basically just come over here, select, and what I can say, can edit. You can call this the battery or BESS. And there we go. So this is it, folks. I hope you have enjoyed the video today. Please subscribe to the channel, give a thumbs up, and I look forward to see you in the next one. Cheers and bye.